In the last video, we discussed data structures and how we can use them to organize and work with data in our programs. Data structures are extremely powerful, especially in data science. You've actually been using them without even knowing it. In this video, we will be looking at the array data structure and at how we can use arrays to work with a fixed number of items of the same type. So far, we have been storing our data in individual variables in our code, or generating the data as we go. This has been great for the simple graphs that we have been drawing so far. However, much of the data that you will get to work with will not be something that you can generate yourself, and in some cases will contain hundreds, thousands, or even millions of items. Let's imagine we wanted to count the number of times the word data appeared in this video. Counting the occurrences of words is actually a very common problem in big data, as it can be used to see how similar documents are, or for finding how often content overlaps between documents. One way we could do this would be to store each of the words from the transcript in string variables like this. But can we actually process them in a systematic way, such as using a for loop? Unfortunately, not for this code. Having a variable for each word value will require us to call each one individually like this. Can you imagine doing this for the hundreds of words in this document? I don't want to imagine it either. Thankfully, when we have a known quantity of data of the same type, we can use an array to store and organize it. Arrays group individual pieces of data of the same type together into a single large block. We can then access our data based on its position as a number in the block. Here we have a simple program that displays the number of times the word data appears in this small part of this video. You'll see that we declare this as an array using square brackets after the type name string. The contents of the array is a list of values separated by commas between a set of curly braces. To use the array, we can access each of the values within square brackets, following the name of the array variable like this. The number inside the square brackets indicates the position in the array that we want to access. In arrays, position numbers start at 0, so the value of word array 0 will be the word here. This is all well and good, but we are still checking each word in our list manually. Because though we're using a numeric value to access the items in the array now, we can now use a for loop to go through each of the items in the array like so. Here I starts at 0, which will let us access the first item in the array, and stops when it reaches the end of the array. We've used the array.length attribute to know when to stop. This is a special attribute that all arrays have. Sometimes we don't know the values that we will be filling our array with before our program runs. In this case, we can create our array with no values in it and fill them later on by using the new keyword followed by the type of the array and the size we want in brackets like this. This program copies the values from the first array to our new array, but in reverse order, displaying the newly copied word. Remember that arrays are fixed-size data structures. This means that once we create the array, we can't change the number of elements it can contain. We can, however, use a variable when we set the size of the array, like this. This means that even though our array can't change size, we can make our program choose the appropriate size when it gets created. Here we use the length of the first array to set the size of the new one. Because of their simplicity, arrays are powerful and efficient data structures that we can use when we know the size of the data that we will be working with. At this point, you might be wondering, what if I want to have an array that can change size after I've created it? That's coming up shortly, but first, let's practice working with fixed size arrays.